So let's keep going, and we're going to talk about sections 11.2.3 and 11.2.4 of the Hein book. Okay, so back to our ever-increasing list of important facts. We start just by stating that regular languages are sets of strings, right? We know that some sets of strings we call regular languages. We don't know what languages aren't regular yet, but there are certainly some sets of strings that are regular languages. And if you have a language that's a regular language, then you can represent it with a regular expression, and we actually explained how you can go back and forth between them. And a regular expression actually represents a regular language. So this is just kind of talking about going back and forth between the two. And then we've got four things here, these last four, that I haven't proven, but I've told you to just trust me and believe it. So if you have a language that's regular, then you can build a DFA to recognize it. And of course, if you have a language that's regular, since we know we can build a DFA, and all DFAs are also NFAs, then every regular language can have an NFA built to recognize it. So if this one's true, then this one's easily true. And I also told you that if you happen to know that a language is recognized by a DFA, so you have a DFA that accepts only the strings in that language, then that language is a regular language. And similarly, if a language is represented by an NFA, then it's a regular language. So right now we've just basically been going back and forth and saying if there's a DFA, you can turn it into a regular language. If it's a regular language, you can turn it into an NFA. But we've been using our wits this whole time to turn things back and forth. And now what we're going to do is we're going to learn a procedure to turn a regular expression into a DFA, or actually into an NFA. And we're also going to learn a procedure for turning an NFA or DFA into a regular expression. And if we can do both of these things, then if we can prove that this procedure works every time, then we really have proven these things that right now I've just asked you to believe me. Okay? So we're not going to prove them in this section, but I'm going to show you how to move back and forth between regular expressions and NFAs without just having to do it kind of by the seat of your pants, as the book calls it, using your wits. Instead, you are going to learn a procedure that shows you how to do it. So the procedure for turning a regular expression into an NFA, which is in the book on pages 710 and 711, is relatively straightforward. You follow the rules and everything works. And so this is actually taken out of the book. This is just an excerpt from the book. And you start out your algorithm by making a machine that's not really a DFA. What it is have the word start with an arrow to a new node you've just made that has an S label on it. So we think of that as the start. And then you also have a node that's labeled F, and this one has a double circle. And what we're going to do is whatever the regular expression is that you want to make a DFA, you're going to write right here, right on the top of there. So, for example, if I wanted to turn A plus B star into a DFA, I would write it right here. So step 2 of our procedure says you take regular expressions that are shown in your graph, like the one we just wrote at the top of the line, and you convert them into simpler and simpler regular expressions until you end up so that every edge has either a letter, in other words, a symbol in your alphabet, or a lambda. So for example, if this is what my regular expression looks like, so it's the sum of two different regular expressions. This rule says I turn an arrow that looks like that into two arrows. Okay? So I'm just going to shrink this page a little bit so I can write. So let's just look at an example of this one. Let's suppose that my expression is my regular expression that I have right here is A or BC. Okay? This tells me that if I have something like that with A or BC written on it, and you can remember that if it says A or BC, that means that I can accept a string if it just has an A on it, or if it has B and C concatenated together. And what this rule is telling us is that that's exactly the same as if you have your two nodes I and J again. But instead of saying A plus BC, you have A on one transition and BC on another. And you can see that we can still get the same sort of string we had before. So we said before we can have an A or BC. If we take this arrow from I to J, and we can still get from I to J using an A, and we can still get from I to J using a BC. So let's just take them and squiggle them up a little bit. Go. And now let's look at the second rule. This one says if you have two regular expressions concatenated together, that's the same as taking the first one and then taking the second one. So again, if we use A as our first regular expression and BC as our second, we might say that that's going from I to J. Whoops, not beautiful, but there you go. Where A is my first regular expression and BC is my second one. And that's exactly the same as saying, let's start with I and transition to another state. Let's call this state 2 for lack of a better name. And we'll continue going to J, where A is on that first transition arrow and BC is on the second one. So if you look, before to get from I to J you had to take an A and then a BC, and now to get from I to J you have to take an A and then a BC. So again, this rule here is just, it's essentially doing what we had before, and we're just trying to do it you know, a little bit more split up, because what we're trying to do, remember, we're trying to turn this thing that started out as a regular expression, maybe a really messy regular expression, and turn it into an NFA. And with an NFA, we can only have a single symbol on every single transition. Okay, so let's take this example, and we'll kind of put it near here. And there we go. And let's go on and look at our third example. Now, the third example is a little bit more interesting because we have an R star, right? And remember, R star means you have some regular expression that you take 0 or more times. So this is kind of saying start at I, do the regular expression R 0 or more times, and then you'll be at J. And here we say start at I, take a lambda jump, optionally do R as many times as you want, and then take a lambda jump and you end up at J. And of course, remember that R star is 0 or more copies of that regular expression. So one of the options for R star is that you would take 0, and that's why we need the lambdas. So let's suppose that my regular expression is actually, let's go back to the A plus BC. All right. So I had A plus BC starred before, taking me from I over to J. And what this is telling us we can do is we can make a new transition from I to J that'll do exactly the same thing. We're going to start at I. We're going to take a lambda transition to a new state. Maybe I'll call it 43 just to show you I can name it whatever the heck I want. I'm going to have a loop on state 43 that has the regular expression A plus BC on it, and then another transition with lambda here. So in the old picture, we started at I, we did 0 or more copies of A plus BC, and then we ended up at J. Here we start at I, we take a free jump. We can optionally, so 0 or more times, go around this thing, and then we take a lambda jump. So again, the same thing. So before we do this example from the book, let's just recall how we do regular math, right? If we're using the rules of scientific math, where we do parentheses first and then exponents and so on. If we have an expression like, I don't know, 54 plus 72 times 3, let's make it times 3 plus 1, but we'll have that parenthesized, and we'll multiply that by 6 to the second power. Then the rules of mathematical precedence say, well, the first thing we need to do is the stuff in parentheses. Then we need to do the exponent, and then we multiply all this together, and the last thing we do is we add, right? And you remember all that. So we're going to do something similar with our regular expressions. It's going to kind of look like we're going to do it backwards. Let me just get rid of this equation that we have here. Okay, so let's suppose that we have a regular expression now, and let's do something that's reasonably complicated. Let's say a plus b starred, and we'll take that concatenated with cb, and we'll concatenate that with d plus b, and we'll concatenate that with abc. Okay, if we have an expression like this, you know, the rules of regular expression in terms of rules of precedence are very similar to the rules of regular math, and I think that's why they chose to use the plus and the multiplication symbol. Remember that when we have concatenation implicitly, we're just kind of putting a dot in between all of these guys. So, oops, and another dot here, right? And so if you think about how we might split this up, what are the important parts of this? Clearly, this a plus b starred piece is kind of a piece by itself that has to get evaluated before we multiply it by these pieces, and this d plus b, because it's in parentheses, has to get evaluated first, and same thing here. And so when we're running it, we kind of do it backwards. We say, well, how would I split this up? Well, I guess I would split it down there and down there, maybe between the C and the B too. And so I would deal with all of these individual parts first, and then once I was done dealing with this piece and dealing with this and dealing with this and dealing with this and dealing with this, then I could do the whole thing. So practically speaking, for this procedure, we're going to kind of work backwards. Remember that, you know, our star has the highest precedence, right? That kind of binds most tightly. And then you can think of that kind of equivalent to the exponent in math. And then we've got our times next and the plus next. All right, so let's just look at how that works in this example from the book. So let's just get rid of this stuff. And let's do the example that we were supposed to do in the book. Turn A star plus AB into an NFA. And as you remember, the first step that we had to do was, for any example that we're doing, we write start, we make this new state labeled S, we have a big transition here to F, which gets a double circle because it's a final state. And we write our regular expression above the line. So we've got A star plus AB. Now, if we look at this and we want to work with this regular expression, we need to figure out where we want to split it apart. What's kind of the loosest connection here? And the loosest connection that we have is that plus symbol, right? Because this star binds like an exponent very tightly, and multiplication binds more tightly than a plus. So we want to split this up across there first. And so what we're going to do is we're going to use the rule to split a plus first. So here's our set of rules. And the rule to split a plus is up here at the top, and it says if you have two regular expressions that you're plussing together, then you turn that into two different transitions like that. So let's just shrink this guy down and we'll copy it. So we have our start state and our double circled final state, and we're going to turn this expression a plus ab, which goes along a single transition, so that the first part goes along the top and the second goes along the bottom. So here's our top transition, which gets an A star, and here's our bottom transition that gets AB. Okay, and now we can keep going with this. At this point, we can choose to deal with either of these transitions. Why don't we deal with the top one first? So let's deal with this A star. So we're going to use this bottom rule here. So let me take what we've got and shrink it a bit. Oops, I forgot to write start at the beginning there. I'll just write it real quick right now. Okay. And so what we're going to do is we're going to copy this whole thing again, except this time we'll leave off that transition and we'll replace it with what we do when we have a star. So here we go. We've got our start arrow. That goes to the S state. We're going to keep our AB along the bottom, going to this final state. But instead of having that A star across the top, we're going to have a lambda to a repeat of A to a lambda. So let's do that. We have a lambda, and we'll send that to a state that maybe we'll just call state 1. And we will have a loop on that state with A not start on it. And then we'll have a lambda down that meets up with that final state. So let's take what we've got now, I'll shrink it, put it there so you can keep an eye on it. And let's take a look and say, is there anything that doesn't have just a single symbol or a lambda on it? And sure enough, this bottom edge doesn't. So that's A times B, or A concatenated with B, which is of this form of this middle one. So let's copy everything except for that transition, and then we'll see how we fix that one. So we have our start with our S. We've got our double circled F at the end. We have our lambda transition to state 1, which has a loop with A on it. And we have another lambda transition back down. And we want to take this AB transition and turn it into an A followed by a B. So we can do that. We'll make a transition with an A on it that goes to a new state. Maybe we'll call it 2. And we'll send that over to F with our B. And now when we look at this example, every single transition has either a single symbol from our alphabet on it or a lambda. So theoretically we should have an NFA. So let's take a look. Let me just take these guys and shrink them a little bit because they're getting a little bit in the way at this point. Alright, that wasn't beautiful, but there you go. Here's the little guys. And we have our nice big one down here at the bottom. So this NFA that we've got down at the bottom is supposed to represent A star plus AB, which means either the strings in our language, well, all of the strings in our language match one of these patterns. Either they're 0 or more A's, so just A's, or it's the string AB. And if you look at our NFA here, that's exactly what happens, right? If you take this top path, you could have 0 A's, or you could have 1 A, or you could have 50 A's if you zoom around like that. And if you take the bottom half, you have an A and then a B, and that's it. So it looks like, at least for this example, the book procedure worked, right? We could turn the regular expression A star plus AB into an NFA. So that's a good thing. So the book gives us a couple more problems to transform from regular expressions into NFAs. Let's try them. And here's our set of rules. I'll just put that in the corner. So let's try this first one first. Let's do the A star, B star. So of course we always begin the same way. We have our start with an S and a big long line, do a double circled F, and we write our regular expression up at the top. So we've got A star, B star. And if we look at this, these stars bind much more tightly than the times, right? There's a little concatenation in there. And so what we need to do is the first split that we do needs to split down there. So the first split that we're going to do is a concatenation split. So that's using this middle rule here. Okay? So let's take this and shrink it down a bit and put it here. And so what we're going to do is we're going to copy again. We've got start. And we will not copy that one transition that we're going to deal with right now. So there's my start and my final. And we're doing a concatenation, so we're following this rule. So we're taking R followed by S and turning it into this. So we will add another state. We'll call that state 1. And from S to state 1, we have A star. And then from state 1 to state F, we have B star. And now we can choose to reduce either of these transitions, either this one or this one first. We know we have to do both of them because neither of them just have a symbol on them. This one has B star, this one has A star. So just for fun, why don't we deal with this transition first? It's of the form a regular expression starred, so we need to use this bottom approach. So let's just shrink that down and let's get started. So we're going to work on that B star, so we'll copy everything except for that B star transition. So there's our start, and we have our start state, and then we have an A star going to state 1, and then we have our final state here. And if we look at how we deal with a star, we're going to add a new state in the middle with the lambda transitions to get us there. So let's call that state 2. And we will have a lambda transition to state 2. We will have a loop with a B on it, and another lambda transition to state F. Good? And so now when we look at this expression, every transition has a symbol or a lambda except for this one, A star here on that transition. So let's go ahead and we'll reduce just that A star. So shrink that, put it there. So we're going to copy everything except for that one transition now. So we have our start and S, and we'll skip copying that one, but here's the one which has a lambda to 2 with a B loop and a lambda to our final state. And now we are changing something of the form regular expression starred. So again, we'll do that same procedure. Didn't leave myself much room, did I? So we're going to have a tiny little transition with a lambda on it to a state 3, a teeny tiny transition with a lambda on it out of state 3, and we will have an A loop right there. And now when we look at all of the different transitions, we see that they either have a lambda on them or a single symbol from our alphabet. And so we're done. And now we can compare our regular expression, which is A star, B star. In other words, 0 more A's followed by 0 more B's. So every string has to have a bunch of A's or 0 A's and a bunch of B's or 0 B's. And if you look, we kind of come in, as many A's as we want, we keep going, as many B's as we want, and we keep going. Now you'll see this isn't the smallest possible NFA we could have. I mean, for starters, I see a lambda transition and another lambda transition right there. But is it an NFA that represents the regular expression A star, B star? You bet. And so we can just stop there and say we're happy with this. And I'm not going to be a real stickler about reducing your DFAs and NFAs unless I say, please reduce this. Don't feel that you have to. Same with regular expressions. Okay, so let's work on that second regular expression now. Let's do A star plus B star. So let's get rid of all of these expressions that we have from the previous problem. And let's keep going and look at A star plus B star. So again, we get started and we draw our start with S to a double circled F, and we write A star plus B star. And we look at that and we say, well, what is bound, what is not bound the tightest, right? What is loosest connected? And we say the most loosely connected is this plus. So we'll get rid of that first. So let's shrink this guy down, and we're getting rid of a plus. So that's this first example. So we write our start. We have our S. We have our double circled final transition. And instead of this single transition across, we're going to turn it into one above and one below. So we get one above that has an A star on it, and one below that has a B star on it. And that looks pretty good. So let's keep going. Let's take this guy, and I'll just put it right there. And now we get to pick. We pick any transition that has a regular expression on it that's not just a single symbol. So maybe we'll do the top one this time. And we will apply the star rule to that one. So we'll copy everything except for that transition. So there's my start and my F and my B star. And of course we're going to apply this star rule. So we will have a lambda to a state 1 and a lambda leaving state 1 with an A loop. And still not fully reduced because we have that B star. So let's shove that one over there. So we have a little bit more room, and we will start. And we have our start symbol and our double circled final. We're going to copy everything except for the transition that has the B star. So I will just keep copying. There's my lambda with state 1 and another lambda down there with my A loop. And we're going to turn this B star into the same kind of thing. So we've got lambda, state 2, lambda, and we'll kind of stick a loop on the side there with a B. And so let's compare, well, let's look at this and say, every single symbol, every single transition has either a symbol or a lambda on it, so we're done. If we just take a look and say, all right, let's see, our original regular expression now for part D was A star plus B star. So that means we accept two different kinds of strings, right? This kind or this kind. We accept strings that have 0 more A's in them and strings that have 0 more B's in them. And if you look at this NFA, sure enough, here's the path you take if you want 0 more A's, and here's the path you take if you want 0 more B's.